All right, the third unit. This is a really long one, and it might be the most difficult of the units. So make sure that you really keep on top of things. Basically, there are two things that we're going to do in this unit. The first is solve trig equations, and the second is identities. All right, we're going to start by solving trig equations. And 7.1 says solving trig equations graphically. You're not going to do graphically. Graphically would require you to use technology to graph this accurately enough to solve. You won't be getting technology on tests or exams, so you're not going to be expected to solve them graphically. But I am going to explain what it means to solve graphically, because I have seen 1-mark questions using graphs. Let me explain the difference. Okay, so it says, in this example, consider the equation 5 sine x equals 3 cos x minus 1. Solve over the domain 0 to 2 pi. So if you picture 0 to 2 pi, that might be something like this. And somewhere there's going to be this is going to be some sort of a sinusoidal graph. Now if you had Desmos or some other form of technology, you could just enter this into the calculator, and you could do that in two ways. Method 1 would be to take 1/2 of the equation and turn it into an equation, and then also take the second part and turn it into equation. So that's kind of like that. Okay, let me use different colors here. If I wanted to graph this, the one in red, that's 3 cos. Okay, so if you remember, cosine looks like this. 3 cos means it would go up to 3 and then down to -3, but then the graph would go down 2. So it would be from 2 down to -4, something like that. Then if you took sine of 5x, right, the sine graph is the one that looks like this, but we're going to go up to 5. So, it would look something like this. I don't know. Something like that. Okay, going up to 5, going down to -5 here. And what we would be doing is looking for the solutions. It would be here and here. Okay, if you did that with Desmos, you would find that these are the two solutions. X is 0.37, so right here, and X is 3.85, right there. Okay, that would be one way of doing it. All right, if you had two separate equations and you wanted to know where are they equal, it's where they cross. Okay, keep in mind, if it ever asks you for this, if it says, what is the solution, and it gives you a graph, the solution is the x values. Okay, now there's another way you could do it. You could just graph this whole thing. Okay, turn it into an equation, graph the whole thing. And so I don't even know what this would look like. Let's make it up, something like this. And it says, now to have this solution, what we would be looking for is where are the x-intercepts. Okay, again, you're going to get the same answers. Okay, so I'm not going to ask you to do that. Now I have seen this question. Okay, I've seen this question. It looks something like this. Okay, I'm just going to put a sinusoidal graph, and I'll put another line through here. And it says something like, using the graph, state the solution for, and let's make this up. So let's say it's 3 cos x plus 1 equals, and let's say that line is 2. So this is the line y equals 2, and this is the line y equals 3 cos x plus 1. So it'll say, using the graph. So it gives you the graph. You never have to supply the graph. It gives you the graph, and it says, using that graph, what are the solutions? Or show the solutions. All you need to do is tell me, what are these points? And when I look for those points, I only want the x values. Okay, I don't want you to say, oh, that point is x1, y2. That is not the solution. There's no y in the equation. If you look in this equation, there is no y. I just want the x values. Okay, so that's sort of the introduction. Let's leave that. Let's get into the kinds of questions you're going to do. You're going to be solving algebraically. Okay, and most of the time it's going to be using exact values, values you already know. Okay, so that's why I have that there. Make sure you have this memorized. Make sure you're familiar with that diagram. Okay, solve for theta. Well, you actually did these last year. Last year you did them only in degrees. This year you're going to do them with radians. So we look at this question, we say, where is sine positive? Here and here. What is the reference angle? In other words, where is sine equal to a half? That happens at pi by 6. Okay, and then we're going to state the answer here. If this is pi by 6, what's the answer in the first quadrant? It's pi by 6. If this is pi by 6, what's the answer in the second quadrant? Well, then you would go, if you needed to do this, if you couldn't remember, you would go pi, take away pi by 6. This is 5 pi by 6. And there are your two answers. Okay, why are there only two answers? Well, because we're only looking for the answers from 0 to 2 pi. Okay, let's try another one. Cosine. Where is cosine negative? Here and here. What is the reference angle? So here's the reference angle, here's the reference angle. Where is cosine root 2 over 2? That's at pi by 4. So, if this is the reference angle, what is the actual angle? That's going to be 3 pi by 4. And what is this one? That's going to be 5 pi by 4. Okay, I'm hoping that this is a little bit familiar to you. You have done these before. Okay, where is tan positive? Tan is positive here and here. This is the reference angle. This is the reference angle. Where is tan root 3? That happens at pi by 3. 60 degrees if you're thinking that way. Okay? And so what is the actual angle? In quadrant 1, it will be pi by 3. In quadrant 3, it would be pi plus pi by 3, so you would have 4 pi by 3. Okay? Now we'll go to the next ones. The next ones you can see are not exact values, so you're going to use a calculator. Okay? So let's try that. Start the same way. Where is sine positive? Here and here. Now we need to figure out the reference angle. So the reference angle is the inverse sine of 0.81. So let's go 0.81 and then go second sine. So the reference angle is, and we're always going to use 3 decimals here, but right now you should keep that value in your calculator. Don't round off yet. Okay, never round off till the last step. So this is, the first answer is going to be 0.944. That's the angle in standard position from the closest x-axis there. To find this one, you're going to go pi, take away whatever's in your calculator. Don't use 0.944. Use 0.944 decimal, whatever you have. Okay? So this is going to be 2.197. Okay, let's try another one. Tan is negative here and here. So we're going to calculate the reference angle. The reference angle is the inverse tan of 1.45. Never, ever, ever use a negative value. The reference angle is always an angle in the first quadrant. It is always positive. Okay, I don't know if you want to make yourself a note. Always positive. Always use a positive value here. Okay? So let's try that. Inverse tan of 1.45. Okay. And I have 0.967. So figuring out my angles, All right, the first one's going to be pi take away 0.967. So I get 2.175. And then the second one is going to be 2 pi take away 0.967. And that's 5.316. Okay, so those are sort of the basic ones. Let's just do a quick review here of the degrees. So this is, how do you know it's going to be degrees? You're just going to see what the given domain is. So this will be like what you did last year. So tan is positive here and here. The reference angle is 30 degrees. So you'd get 30 and 210. Okay, cosine is negative. The reference angle is 60 degrees. And so you'd have 120 and 240. Okay, where's tan 0? Is that positive or is that negative? Well, it's neither. You should actually know that tan is 0 here and here. So my reference angle is 0 degrees. So I'm going to have 0, 180, and 360. Okay, we'll just do a couple more here. These are using a calculator in degrees. So now you got to change your calculator into degrees instead of radians. Okay, so let's take, and remember that you're going to use the positive value. Okay, so let's go 0.38 and then second sine. So I think you should have 22 degrees here. So theta will be 180 plus 22, so 202. And then 360 take away 22, that will be 338. All right, next one, cosine is positive here and here. And if you take the reference angle, you have a problem. It says error. Now, what does error mean? Well, think back to the cosine graph. What's the biggest value you're going to have for the cosine graph? 1. There is no place where cosine is 1.76. All right? So this means there is no value that's going to work for that. So we're going to say no solution. If you like, you could answer it like this. You could say, here's my set, and I'm putting nothing in there, the empty set. Okay. Let's try tan is negative here and here. Let's figure out what the reference angle is. So we're going to take the inverse tan of 1.89. So 1.89. So the reference angle is, notice with degrees, we're going to round off to the whole degree. There will be no decimals with degrees. So 180 take away 62, this will be 118. And then 360 take away 62 will be 298. All right. I think we can stop there. There is a handout with questions on trig equations. So you're going to do the questions from examples 1 to 4. Okay, shouldn't be too difficult, shouldn't take you too long.